All right, welcome back. We are going to try to finish up chapter 8 this week. Hopefully we can do that in the next couple of videos. And then that should be it for the content for this semester. I will then open up test 5, which will only cover chapter 8, and then I will also activate a final exam, which will be comprehensive. So it will cover all the way from chapter 1 to chapter 8. All right, so let's continue where we left off. So this was the last example that we did in the previous video. So we will just sort of move on to the next slide. So this talks about what the discriminant of the quadratic formula is. And essentially the discriminant is basically the radicand of the quadratic formula. So the b squared minus 4ac part. So this part of the quadratic formula will tell you about the type of solutions that you are going to get. And the next slide will kind of cover that for us. So if we have a positive in the square of an integer, so basically a perfect square, we are going to get two rational solutions. So we saw that in the last video when we did our quadratic formula introduction. Remember, if it's a perfect square, that means the original quadratic was factorable. So you could always go back and double check your answer. If you get a positive number for your radicand, but not the square of an integer, so you get 17, you get 44, I think was an example that we saw already. You're going to get two irrational solutions. So you're going to have a radical as part of your two answers. If you get a 0 as your discriminant, then you're just going to get one solution. And the reason for that is because, remember, you're doing the positive, negative, plus or minus the square root of some value. Well, the square root of 0 is just 0, so you're not adding or subtracting anything. So you're just going to get whatever the opposite of b is over 2a. So this part kind of cancels out, and you don't really have two solutions there because you're not adding or subtracting any value at all. And then last but not least, if you have a negative in here, we can go ahead and do that now. We talked about it on Friday. We talked about it in the previous video that you are going to get two non-real complex solutions, imaginary solutions. So I is going to be invited to the party. Okay. So we are going to find the discriminant here. And essentially, we're not going to solve this. We're just going to figure out whether the equation can be solved by factoring or whether the quadratic formula should be used. So essentially, this is what we're going to do. Is we are going to take the b squared, so negative 1 squared, minus 4a and c, and we're going to see where that takes us. So this is going to be 1, and then this is going to be negative 40 times negative 2 is positive 80. So 1 plus 80 is 81, which is a perfect square, which means this is factorable. Okay, so you could have factored this to get your answer. So if you just do the b squared minus 4ac part, so again, b squared minus 4ac part, this is the discriminant, that will tell you whether or not you could factor it and what type of solutions you're going to get. Okay, so this could be factored. All right. So let's take a look at this one. Again, we're going to just take a look at the b squared minus 4ac part. So we've got b squared minus 4a and c. Remember, this needs to move over to the other side of the equation. So it ends up being negative 7 over there. So this is 1, and this is going to be 12, or negative 12 times negative 7 is going to be, let's see, 84. Okay, so that gives us 85, and this is a positive result, which means we're going to get irrational solutions, right? Because this is not a perfect square. I don't know if it can be simplified. Hint, hint, hint. So it's one of those things where it just tells you that you cannot factor this. So you cannot factor. So the best way to do this problem is to go ahead and use the quadratic formula. All right, so last but not least here, we're gonna go ahead and do the b squared, and it doesn't really matter if it's negative or positive in here, because when you square it, it's just gonna be positive anyway, so that's the good news. So we've got the b squared minus 4a and c, okie dokie. So this is going to be 1600, and this is going to be 4 times 25 is 100, times 16 is also 1600. So this is going to be 0. So this means that we are going to get just one solution, and what that tells us is that this was a perfect square trinomial. So this was a perfect square trinomial since we got 0 as our discriminant, which means we're only going to get one answer, which means that this quadratic only crosses the x-axis one time. So the vertex is on the x-axis. All right. So that takes us to 8.3, which is equations in quadratic form. So this is kind of pulling everything together that we've talked about so far over the course of the semester. We're going to need to know how to factor. We're going to need to know how to use the quadratic formula, potentially completing the square if you're into that sort of thing. So we will have to do a variety of techniques, clearing out any denominators. So we're going to have our work cut out for us in this section for sure. All right. So let's go ahead and solve this. Can't see, it's in the way. Get out of the way. Solving a rational equation that leads to a quadratic equation. So again, first thing that we see is that we've got some x's in our denominator. So what we should do is we should figure out what our domain is. So x such that x cannot be equal to, so x cannot be equal to +1 or 0. So again, this brings back things that we've talked about in the past, where if we get either one of these solutions, we're probably not going to get an actual answer anyway. All right, so this is x can't be 1 because 1 minus 1 is 0. X can't be 0 because 0 is in the denominator here. And again, you can't have 0 in the denominator. So what we need to do is get rid of all of these fractions, and we do that by finding the LCD. So our LCD between the two denominators that we have is going to be x, and then x minus 1. So this is what we're going to multiply by. Each and every one of these terms by this LCD, things will cancel, some things won't, and then we'll go ahead and simplify what we have left. So when I take this LCD and I multiply it into this equation, that's going to give me 4x, because the x does not cancel, but the x minus 1s do. That's going to give me plus 9x parentheses x minus 1, and I'll simplify that a little bit later on, is equal to, this time the x cancels, but the x minus 1 does not, so that's going to be -7 x minus 1. So all of this happened by multiplying by this LCD, and now we're going to go ahead and get rid of our parentheses, and hopefully we'll be able to figure out what to do from there. So we've got 4x plus 9x squared minus 9x is equal to -7x plus 7. And now that I have this quadratic term, we probably want to move everything to just one side of the equation, since most of the strategies that we have deals with our quadratic equal to 0. Whether we're factoring or we're using the quadratic formula, we want to make sure that our equation is equal to 0. So we'll move everything to one side, so that gives us 9x squared, and that's going to give me negative, let's see, that's -5 plus 7, so that's plus 2x, and then minus 7 is equal to 0. Again, remember, you have to combine these terms. So positive 4x minus 9x is going to be -5x. Add 7x, you get your 2x. And then, of course, subtract 7 to both sides. And then the next thing that we do is these I check to see if I can factor this, and I definitely can. So my factors of -63 that add to +2 are +9 and -7. So that factors to be x plus 9, x minus 7 is equal to 0. But remember, your a value is 9 here, so we've got to scale these back down. So that's going to be x plus 1, and 9x minus 7 equals 0 through factoring. Okay, whether you use a factoring by grouping or whatever other method of factoring that you like to use, these are the results that you're going to get. And then we are going to check our answers. So we get x is equal to -1, and we are going to get x is equal to 7/9. Remember, opposite divided by will give you the solutions that you're looking for. Okay. Any questions? Oh, that would be if I was teaching this on Fridays. Sorry, I'm a little disheveled. My daughter broke her arm yesterday, so things have been a little crazy in the Moniz house. But we'll get through it, figure it out, and we'll see. So, okay. I suppose if you have questions, you can ask me the next time that we meet, which may not be on Friday. I should probably bring that up now. Friday I have, as my daughter's going in for surgery for a broken arm, so I don't think I'm going to be able to meet you guys on Friday, but I will post another session later on in the week, or possibly even Thursday, to see if anybody can meet me then. And if not, then I'll be flexible and obviously try to meet your needs and answer some questions that you may have at a different time. Okay, so I do want to let you know that I probably will not be around at 11:30 on Friday because of surgery. I might be. I'll let you know once it's scheduled. I know that it's Friday. I just don't know what time. So just bear with me on that. All right, so this is an interesting question. Things are definitely going on in this problem, and it makes me feel like we should be able to get our answer really fast, but we cannot. So in 1 hour and 45 minutes, Cody rows his boat 5 miles up the river and then comes back. So a total of 1 hour and 45 minutes is how long it took for this to happen. And we know that he rowed 5 miles upriver, which means he rowed 5 miles down the river. And then they told us the rate of the current, because obviously he's in a river, so this river is flowing, and it is flowing at some average speed of 3 miles per hour. Okay, we're not assuming that there's like a rainstorm that made the river flow faster in the middle of this thing. It was sort of just this constant 3 mile per hour river that was going on. We can figure out how fast he is rowing based off of this information. Okay, so the first thing I want to think about is it doesn't take the same amount of time to go up the river than it does to go down the river, because obviously it's going to take him longer to go upriver against this current that's going 3 miles per hour than it will take him to go down the river, which that current is helping him go faster. All right, so we can't just divide this in two and say, all right, it's going to take him, whatever amount of time to do this. So we can't do that. All right, so here's sort of like how I map this out. We have this T1, however long it took him to go up the river, plus this T2, which is the amount of time it took him to come back from this journey, is equal to some total amount of time, which, good for us, we actually have that. So I'm going to write this as an improper fraction, if that's cool with you. So this will be 7/4 is our total time. Instead of writing 1 hour and 45 minutes, that's not cool. Or the decimal version, we don't want that. So I'm going to use the distance formula now. So the distance formula to figure out what these rates are. Okay, so what these times are. So distance is equal to rate times time. All right, so this will be T1. And then I have to use the distance formula again to figure out what T2 is. Okay, So the distance we know is 5 miles, whether they're going up the river or down the river. So we've got 5 is equal to R and then T1. And then we have 5 is equal to R and then T2. And the cool thing about this R, this rate, is that it is directly related to how fast this person, Cody, is rowing and how fast the current is flowing. So up the river, the current is slowing Cody down by 3 miles per hour, where down the river, it's speeding him up. So it's making him row faster. So we're going to be able to say that the rate is going to be x minus 3. So x being Cody's speed. So I'll define that over here. So x is Cody's speed of rowing, okay? So however fast he rows, subtract 3 miles per hour from it, and that is the rate of rowing when he's going up the river, and it's T1 here. And then on the flip side, when he's coming back down the river, this 3 miles per hour is making him row faster, so he's going to be x plus 3, because he's going, again, however fast he's rowing, plus this 3 mile per hour that the river is taking him down. So T2. And now if I'm using this formula up here that I see, which this T1 plus T2 is equal to total time, all I have to do is solve these guys for T, right? So I'm going to divide both sides by x minus 3 here and divide both sides by x plus 3 there. So that's going to give me T1 is equal to 5 over x minus 3, and T2 is equal to 5 over x plus 3. And now that I have these, I'm going to use substitution to write a brand new equation which says 5 over x minus 3, which remember is my T1, so this guy is done, plus my T2, which is 5 over x plus 3, so T2 is done, is equal to 7/4, which is the total amount of time that is traveled. And now we have something very similar to what we saw before, which is to solve these equations for x. So we should do that by saying x such that x cannot be equal to 3 or negative 3. And the LCD between these denominators is 4, x minus 3, x plus 3. So when you multiply this LCD into everything that you have here, you are going to get 20 parentheses x plus 3, because remember 4 times 5 is 20, and the x minus 3's will cancel. Over here, 4 times 5 is 20 again, and the x plus 3's will cancel, which leaves you with the x minus 3, is equal to, this time the 4 cancels, and you are left with 7, and then x plus 3, x minus 3. All right, because again, only the 4's cancel here. And now we start to simplify what's going on here. So that's going to give us 40x on the left-hand side, because 20x plus 60, 20x minus 60, so the 60s will cancel. We know that this is a difference of squares. This is going to be x squared minus 9, and then I can just multiply that by 7, which is going to give me 7x squared minus 63. And again, we want everything equal to 0, so this is going to be 0 is equal to 7x squared minus 40x minus 63. And I believe that this is factorable. I believe it's 9 times, let's see here, let's figure this out. 9 times 49, I believe. So 9 times 49. Yep. Good. So we've got 9 times 49. Those are my factors. So this is going to be 0 is equal to x minus 49, x plus 9. and our A value is 7, so I've got to scale these back down. So 0 is equal to, this is going to be x minus 7 and 7x plus 9. And then I solve these. So I get x is equal to positive 7, and I get x is equal to negative 9/7, which I am immediately going to cancel this guy out, the last one, because x is Cody's speed, and he cannot row negative 9/7 miles per hour. So 7 is Cody's rate of rowing. This was an awful lot of work, as you can see. I will try not to torture you guys with too many of these word problems on the tests and the final exam. But I do need you to know that they exist. And even though it seems like there's not enough information in the problem to be able to solve for what Cody's rowing speed is, we certainly were able to do that. But it wasn't easy, but we were able to do it. Okay. All right, so this is familiar to us. We know how to solve these. These are radical equations. And remember, in order to solve this, we need to isolate the radical. Don't forget to do that. So we are going to subtract 1 to both sides, which gives us 2x minus 1 is equal to the square root of x. And then in order to solve this radical equation, you need to square both sides. So when you square both sides, you get just the lonely x over here on the right-hand side. You get 4x squared minus 4x plus 1 on the left-hand side. Remember, when you square this and square that, you need to do the binomial multiplication here. You cannot just square the first and square the second. It doesn't work that way. That exponent rule doesn't exist. Move everything to the same side of the equation. So that's going to give us 4x squared minus 5x plus 1 is equal to 0. And we check to see if this is factorable, which it is. My factors are x minus 4 and x minus 1, which is equal to 0. And again, my A value is 4, so I've got to scale these down. So x minus 1 and then 4x minus 1 is equal to 0. And now we can solve these. So we get x is equal to positive 1, and we get x is equal to 1/4. Don't forget to check these solutions. Remember, you can be given some extraneous solutions here, which means one of these may not be valid. So I'll check this one to make sure that everything is legit. So 2 times 1, 2 times 1 is equal to the square root of 1 plus 1. Is that true? Yes, it is. So this is a valid solution. Now I'm going to check this one. 2 times 1/4 is equal to the square root of 1/4 plus 1. And 2 times 1/4 is going to be 1/2 is equal to, when you take the square root of 1/4, you get 1/2 plus 1, which is not equal anymore. So this is not a valid solution. So we're going to cancel that one out. The only valid solution is x minus 1. So remember, when you square both sides, you are probably going to be given some extraneous solutions, especially if you have a quadratic, because quadratic, we generally get more than one solution. All right, but in this case, one of these solutions was not valid. All right, so let's take a look at this one. This just takes us down memory lane. It feels like it's not a quadratic because we have an exponent of 4 here and an exponent of 2 here. So it doesn't have that ax squared plus bx plus c form. But all these exponents are just twice as big. So what we can use, again, is u substitution. We can take the x squared out and replace it with a u. So I'm going to set my u to be x squared, which is some value that I don't know. And that's going to give me 9u squared minus 37u plus 4 is equal to 0. And then I'm going to go ahead and factor because this is indeed factorable. So 36, that adds up to negative 37. So that would be u minus 36 and u minus 1. okay, is equal to 0. And our a value is 9, so we've got to scale these down again. So this is going to be u minus 4, and 9u minus 1 is equal to 0. And then we solve again. We say u is equal to 4, and we say that u is equal to 1/9. But remember, we're not solving this for u, we're solving this for x squared. So we're going to put our x squared back in. So this is going to be x squared is equal to 4, and this is going to be x squared is equal to 1/9. In order to solve for x, you got to take the square root of both sides, which means x is going to be equal to positive negative 2. Remember, when you take the square root of both sides here, you're going to get the positive and negative version here, because if you square 2, you get 4. If you square negative 2, you get 4. And you take the square root of both sides here, and you get x is equal to positive negative again. This time it's 1/3. So we just got 4 solutions, which should not shock anybody in this class, because we had a degree 4 polynomial over here. And we've talked about this in the past, where it says that the degree of the equation will indicate the maximum number of solutions that you're going to get for the problem. We just got 4. We have a degree 4 equation. That is not a coincidence. That will happen more often than not. Okay? Excuse me. All right, so this is just directions on how to solve quadratics by substitution. We did this way back in the day. These directions are still exactly the same, okay? So once again, we could solve this using u substitution again. If we set our u to be x plus 3, and then we can just take this x plus 3 out and replace it with u. So this is 5u squared plus 9u minus 2 is equal to 0. Remember, you want everything the same side of the equation. This is factorable, so u plus 10, u minus 1 equals 0, and our a value is 5, so we bring it back down. U plus 2 and 5u minus 1 equals 0. And then once you sort of like get to this phase, you can write this as u is equal to negative 2. You can write this as u is equal to 1/5, and then you can bring your x back in. So you have x plus 3 is equal to negative 2, and you have x plus 3 is equal to 1/5. And then you solve. So x is equal to negative 5. So there's this guy. And then when you subtract 3 to both sides, what I would suggest is maybe write this as 15/5. So that way, you know that you can subtract these. So that will give you x is equal to negative 14/5 as your solution. Remember, when you have 1 minus 3, it's 1/5 minus 3. It's really 1/5 minus 15/5. That's the version of 3 that we need to subtract by. Okay, so easy peasy. Just kidding. Just kidding. Yeah, u substitution. This is more for you students who are going to continue on to trig, pre-calc, calculus. You'll need to make friends with u substitution quite a bit in calc. All right, so further form applications and formulas. This is 8.4, obviously, and we'll go ahead and do some more of these, applied problems. You can see applied, applied, applied. So we'll do some more word problems here. All right, so let us solve the formula for the specified variable. So this is similar to what we did a long time ago in chapter 1 when we solved for some other random variable, except now we have, higher exponents, or we have square roots to deal with, but it's more or less the same thing that we did back in chapter 1, just slightly more complicated. And I'm just going to leave this out because, technically when you take the square root of both sides, you need the positive negative version. But since this is an area formula, we're finding the radius. This is the area of a circle, pi r squared. Radius can't be negative, so we will go ahead and just leave that part out. Okay. So to solve for r, we need to get rid of the things that are not supposed to be here, which is pi and this square. So I'm going to divide both sides by pi. which gives me a over pi is equal to r squared. So it looked like that was pretty straightforward. And then I'm going to take the square root of both sides. So I'm going to take the square root of both sides, which gives you r on the right. So far, so good. The problem is you have a radical in the denominator. You cannot leave that radical in the denominator. You know that, I know that. So we are going to fix this by multiplying by the form of 1 that we need to use to get rid of this radical in the denominator. So I'm going to come up here since I've officially run out of room down there. So this is what I'm staring at right now. And I need to fix this by multiplying by radical pi over radical pi. So I'm going to multiply by radical pi over radical pi, and that will just give me pi in the denominator, which is fine. And that gives me the square root of a times pi in the numerator. So there it is. We have now solved this for r. It's not violating any of the conditions of a simplified radical. So we did everything that we were supposed to do here. This time we're solving for a. So a is in here. So we've got to untrap it under this radical. And there's a couple of ways to do that. You can either square both sides right now, or you can divide by 30 first. It's really entirely up to you. You get the same answer either way, as long as you are, not making up any rules. So this should give us s over 30. I'm just going to divide both sides by 30 first, is equal to the square root of a over the square root of p. I'm also going to divide and conquer there. Multiply both sides by square root of p, and that gives you s square root of p over 30 is equal to the square root of a, and then you can square both sides. So that's going to give you s squared p over 900 is equal to a. So quite a bit of work. Not as much work as this one, because a lot of students fall into the trap of thinking that this is their answer. So this is a trap answer because they forget that you cannot leave the square root in the denominator. But over here, we did everything that we needed to do. We get this conveniently, you got p out of a radical too. That doesn't really matter since it's not in the denominator. But everything here is the way that it's supposed to be. All right, so this one's kind of neat for a lot of students because they're like, well, at first glance, they look at this and they say, I have too many variables, right? We've never really dealt with a quadratic that has a multivariable situation, right? And so far in this lecture that we've talked about, everything that was in the equations was factorable. So I factored everything to get my solution. And normally in class, I would have students try this one. I would say to you, go ahead and solve this for t. And most students just kind of hit a wall. And they're like, I have no idea what I'm supposed to do with this. But remember, if you can't factor a quadratic to get your solutions, your very next step should always be to use the quadratic formula. So your a here is 2, your b here is -5, and your c is k. I know it's weird, but your c is some k, right? Your constant is k. We don't know what the constant is. And I won't get a nice, clean answer for this problem because I have too many variables anyway. So this is going to be t is equal to plus, let's see, the opposite of b, so 5, plus or minus the square root of b squared minus 4ac over 2a. And we've substituted everything that we needed to substitute, and now we're just going to try and clean it up as much as possible. So 5 plus or minus the square root of 25 minus 8k over 4. And believe it or not, this right here is the answer to this problem. There's nothing else that we can do to this. We can't factor anything out. We can't take the square root of this. We won't be able to do anything to this problem until we know what k is. And since they didn't give us any indication what k is, this is what we've got to work with. This This is now officially solved for t, because t is by itself over here, right? T is playing the role of x in the quadratic formula. All right. So don't get like scared when you see these multivariable situations, especially when you have a quadratic. If you can factor it, factor it. If you can't factor it, use the quadratic formula. That's got to be your mindset going forward. All right, this will probably be the last one for this video, and then I'll post the rest of chapter 8 in another video, probably tomorrow, maybe later on tonight. So a rectangular reflecting pool in a park is 20 feet wide. So you can see that here. It's 20 feet wide. There she is. And it's 40 feet long. So there's 40 feet long. The gardener wants to plant a strip of grass that is a uniform width around the edge of the pool. So they want some strip all the way around here so that it's a uniform. So they don't want it to be like 15 feet on that side, 12 feet on this side, 8 feet on. They want it to be completely uniform and symmetric, just the way I like it. All right. And then she has enough grass seed that she purchased to cover 700 square feet. And how wide will the grass strip be? And most students know that the area of a rectangle is the length times the width. And this is the formula that they immediately go to, right? And they go, oh, they gave me the area. The area is 700 feet squared. So far, so good. So they say that the area of this is going to be 700, and we can leave the units out for now, is equal to my length times my width. And when they look at this, they go, oh, my length times my width, it's right here. They gave it to me. It's this 40 plus 2x, that's my length, and my width is 20 plus 2x, right? They kind of drew it right here in the picture for me. And then they start to bang this out because they go, all right, area is equal to length times width, and they start to do the calculations here. This is a big problem. This entire length and this entire width factors in the pool here. You do not want to plant any of this grass seed in the pool. You want it to be around the pool. So before you start diving into this, you've got to subtract the area of the pool, which is going to be 800 square feet. All right, don't forget that when you're starting to think about these problems. So you need to take everything into consideration before you really dive in. All right, so I'm going to start to clean this up as best I can. So I'll add 800 to both sides, which will give me 1500 is equal to. And the next thing I'm going to do is I'm going to factor a 2 out from both of these. So when you factor a 2 out here and a 2 out there, you end up with a 4, right? Because 2 times 2 is 4. And that gives you 20 plus x, and that gives you 10 plus x. Again, I got this 4 by factoring out a 2 from each one of those sets of parentheses. And then 1500 divided by 4 is going to be 375 is equal to, and then I will also FOIL this out. So this is going to be x squared plus 30x plus 200. So far so good. I will then subtract 375 to both sides. So 0 is equal to x squared plus 30x. And then this is going to be negative 175. All right. So we've got 175 that we're trying to look for factors of this. So 175 is divisible by 25. So we can see where that takes us. So 25, and that's 7. So that's not going to work. So 175 divided by 35, and there it is. So 175 is divisible by 35, which is 35 and 5. So this is factorable. So 0 is equal to x plus 35 and x minus 5. And when we solve these, we get x is equal to negative 35, and we get x is equal to positive 5. We're immediately going to cancel this one out. It means nothing to us. because X represents the border, and you cannot have a negative 35-foot border, but you can have a 5-foot border of grass around this pool. All right, lovely grass strip around the pool. All right, so that is it for today's, at least for this video. Like I said, I'll either post the next one tomorrow or later on tonight, depending on how things are going here at my house. All right, so thanks for listening. If you have any questions, send me an email. I will definitely reach out to you to let you know about Friday within the next couple of days. We have to call, I think, tomorrow or the next day to figure out what time we're supposed to go for the surgery. All right, thank you very much.